time for an update. That's where I was focusing most of my work. That's 12AU7. Half of it is a DC restore, half of it is a sync inverter. Working on that really made no difference. Right above it is the 6AL5 horizontal discriminator, I believe. I'm not quite done with it. But doing this work right in here had no discernible change. So I took a look at the schematic, and because I do have sound, so I'm thinking, well, how can I have sound and no video since the sound comes off of the video amp? Here's a video amp. The sound comes off the plate and goes to the left, and the video comes off the plate and goes to the right. Well, okay, if the stuff on the left is kind of working and the stuff on the right isn't working, let's go this way. So here's that DC restore. That's half of that 12AU7, so I replaced this stuff. But I haven't replaced that. That's kind of, the most obvious thing between here and the picture tube. We have that. So where is that? That is the single most inaccessible component in this chassis. It's that guy. I managed to clip one end of it out. The other end is buried behind a clump of stuff, including some rather fragile peaking coils. But that's the goal. So I thought I'd sort of start working on this terminal strip and work my way towards it. And it turns out this stuff is the audio, the 6T8 ratio detector, and I guess first stage audio amp is back there. Replaced a few of these caps and the sound got better. So that's encouraging. Now, one thing I wanted to point out to you guys is down in there on that 6T8 ratio detector, we have a 1 microfarad electrolytic. This guy. 1 microfarad, 50 volts. So I could replace it with a modern 1 microfarad electrolytic. However, that would be so tiny. To give you some idea, I don't even stock electrolytics that small normally. That's a modern 10 microfarad electrolytic. A 1 microfarad would be even smaller. It gets kind of silly. So when things get that small, when they're 2.2, 1 microfarad, I actually go with plastic film. There's a couple options. Here's an axial 1 microfarad 250 volt cap, way more voltage than I need. And here is a radial lead version of it. I think it might also be 250. I'm not sure. I have to look up that voltage code. Either way, either one of these will work fine. I'll go with this guy. Yeah, okay, electrolytic 1 microfarad cap would be like 10 cents. This might be a couple bucks, but that's what I'm going to go with. It'll be easier to work with a larger part with longer leads when it comes to installing it. So I'm going to get that guy in there. There's some power resistors to replace, and I'll replace that that 0.1 microfarad, then I'll try powering it up again. Now something else, the switch. I unbent this, and when I powered it up, I had the screen was blank. Because I realized when I freed it up, one of these just came out. And I did to reinsert it to get the video back. So the switch is damaged, and as I suspected, they froze it in place so they could get a watchable image. But I was playing around with it because I was wondering, that opera button, it seemed like it was just a momentary thing. You'd push it in, you'd let go, and it would pop back out. No, it's actually a toggle switch. Check out this rather clever action. There's this brass piece that has a notch at either end. If I push it in, it hits this thing on the right and rotates a little bit. I let go, the other end catches on a piece of metal. So it's sort of, it came back a little bit, but not all the way. So it's in the in position now. And if I let go, it comes out all the way. So, one mode. So this would be the opera mode. The word enlarges the image, and this would be the non-mode. But it's broken. So, just as I did that, this came out again. So I'm going to jam it in there like it was so I can keep working. But at some point I will detach this. Looks like I just need to take out these 2 screws, and I'm just going to have to try to figure it out. And ideally repair it. If not, I'll try to find something online. A push toggle switch is certainly not unheard of. It's just a matter of finding a modern switch that could mount somehow in this and would be compatible with the shaft that pushes down on it. Alright, it wasn't easy, but I finally got it. There's another one that's also quite difficult to get at. It has a bit of a crack in it. We'll get that next. But after doing all this work, I want to see what difference that might have made before I tackle that next difficult cap. Here we go. And by the way, this set draws quite a bit of power. A little over 2 amps. So, there we go. An odd pulsing sound. Well, that looks different. We lost some height. Whoa, wow, the sound is way louder.
Like me?
Booming. It seems like there's more definition on the screen. Playing around with the tuning dial right now. I think we still see that's vertical, horizontal. Yeah, I'm gonna try manipulating the horizontal oscillator coil.
May enjoy making.
So just making sure I have contrast maxed out. Brightness down a little. Sure, seems like there's something there. Okay, the question is, what's the horizontal frequency coil? Oh yeah, that's it. Almost. We have horizontal lock. How about that vertical? Hey! Whoa! Still have that ticking, which might be horizontal. There might be some high voltage arcing somewhere.
It's only temporary, isn't it, honey? Back about 9 o'clock.
I haven't gone over the vertical yet, the vertical integrator and vertical oscillator. I suspect that will help out.
I think the tower was the most fascinating place of all in London. I didn't want to go there, but my husband insisted. You know, all those people.
So I would say at that point 1 microfarad cap was indeed the smoking gun, for lack of video. Alright, cool. So I'll go after the vertical circuit next. Okay, vertical. Vertical is also in a very challenging area. It's these two tubes down here. Now, this is on the opposite side of the chassis. I'm not taking this side off because we have several large transformers attached to this plate. And the wires are stiff and crusty, and I do not want to disconnect them or have them hanging from the leads, so I just got myself in there as best I could. This was a huge paper cap we saw earlier. It was 0.25 at 600 volts, been replaced by this little guy. And two up here. Vertical circuit runs at much lower frequency than horizontal, so you tend to have much larger capacitor values. I replaced these three so far. These are in the oscillator circuit. The the vertical integrator circuit is down here, where we have a 0.0022 and 2.0047, super common vertical integrator component values. Those I haven't gotten to yet because they're in there. But anyways, I've powered the set up again, so let's see what we have now.
The first 25 callers will receive a...
Still excellent sound.
Social Security disability. You're facing a legal system with its own rules and judges. Most people get denied.
They're way more height than we had before.
I'm Tom Nash.
I'll reach around back here and adjust that a bit. Oh yeah, we get way more height than we had before. But still can't quite get it to lock. It seems like I can lock on here. It's probably running at 120 hertz instead of 60 hertz. So that wouldn't be so much the integrator. That would be the oscillator. Oh, there's one cap I didn't get to yet. Boy, I don't know if you guys can see it, but it's down there. Also, I haven't checked the resistors. Now, given how far off the resistors are on the rest of the set, it wouldn't surprise me if those were bad. Take a gander at the schematic too. It's just two basic ways to do the vertical oscillator. One was with a transformer, and one is with an RC time constant. And what did they choose to do? Oh, there is a blocking transformer in there. Okay, okay. I'm not sure where it's hiding in the set, but somewhere down here. I'm pretty sure it's a vertical output transformer. A blocking oscillator transformer would not be anywhere near that big. For example, I just happen to have one here I pulled out of an RCA I was working on, so it'd be something about that size. Maybe it's on top of the chassis somewhere. I don't know. I'll have to look at the parts placement diagram. And this only has two wires. I think this is a filter choke. I think that's the audio output transformer. So I don't know where it's tucked away. Anyway, these tend to make the set a little less susceptible to component values, but you definitely have RC as well, for example. That 0.1 and 3300. So what does that transformer do? It provides feedback. So you can see it's taking the output, the plate circuit there, and it's feeding it back to the grid. That's what keeps the oscillation going. You need to have some feedback. You want controlled instability, basically. So there's the 0.25 I replaced, and I replaced the 0.1. I replaced a 0.033, but I don't see that on the schematic here. Huh, wonder if that was a production change. Maybe that 0.22 became a 0.033. I don't know. So the one I didn't replace yet, I think it's another 4700 picofarad. Oh, it's that guy. I haven't replaced the feedback capacitor. yes, that could definitely have an effect on the frequency, as could these resistors. For example, that 6.8 meg in the vertical hold control. And considering how much the value on some of these resistors has drifted, where they're 2, 3, 4 times the value they're supposed to be, that seems likely. There's a curious thing about that, though. It seemed the general trend I've seen in this set and others is that the higher the resistance value is, the less it drifts. Like example, a 1 meg resistor would maybe go to 1.1 or 1.2 meg, whereas a 100 ohm resistor might be 400 ohms, like 4 times the value versus going up by 20%. So the vertical hold control, that's a vertical and horizontal hold. So I'll trace out this wiring. So it goes right over there. I think that's the 6.8 right there, although it looks more like a 1.8. Or no, I think it's right next to that cap I need to do. It's hard enough to even see these things, let alone get in there and test them or replace them. This is not only deep, but we have this transformer in the way. But I'll get in there. I'll get in there. So I've gotten fairly good, like soldering in these caps, of kind of threading the needle, moving some wires out of the way, and getting way down in there. One of you joked about buying, I think, like a 2-foot-long soldering iron in the comment section. Not quite, but almost. That's about a foot in there. So one trick I've been doing is tinning up the lead to the point where there's a glob of solder on the end of the component lead, bringing it in there and then heating up the terminal and just letting it all melt together, rather than trying to feed in solder at the same time. I'm trying to hold a component lead, feed in solder, and holding a soldering iron. I need 3 hands to do that. It gets a little tricky. I got in there and replaced that 0.0047 feedback cap, and what do you know? We have lock. I'd speculated about earlier what it was like to tune this set. It's a little odd. It's not terrible though. I'm trying to get enough light that you can see what I'm doing, but not wash out the picture. There we go. So you get more range than I thought you'd have. You can rotate this a good like 10 degrees, and you still have the image. And a pretty good sound throughout that rotation range, too. In fact, I even have sound when there's virtually no image left on the screen. So it's actually fairly easy to tune in. So that's a good thing. So not too shabby, not too shabby. Still have more caps to go. What do we have left? Oh, by the way, bright lighting is essential while working on this. I have several overhead floodlights I've been shining in at various angles to get all the nooks and crannies. Well, let's see. Still have the vertical integrator, but as you can see, it's working as is. It's not much voltage at that point, so that doesn't really surprise me that those aren't really affected by leakage. It's a really small signal level. So the very first resistors I talked about when I started poking on this set I haven't touched yet. And behind those are the power supply caps. Now, obviously, it's working fairly well on the original electrolytics. However, I am going to replace them because the owner of this set is giving it to a relative who does intend to use it. So I want to make sure that I do the best job I can to make it reliable. We'll probably put in a full set of fresh tubes as well. So we have a little bit down there. We have 3 paper caps. We have that guy, obviously, and the electrolytics. And there are a few up here. What is that guy? I believe that's the video output tube. So I replaced the capacitor coming out of it, but I didn't replace all the parts associated with... Oh, no, I'm sorry. That's the video output tube. I did complete work on that. That's a horizontal output tube. I haven't done anything with that yet. That I definitely want to go over. I already checked that resistor. That's a fairly critical one. That's the cathode bias resistor. That will have an impact on how much current is flowing through that tube. And we don't want to push it hard, which would shorten its life or burn up the flyback. It is a little over 100 ohms. I'll be replacing that guy. Let's see, I got the line filter caps. This is all done. So yeah, a little bit of work up here, a little bit of work down there. I did spot check resistors all through the IF. They're pretty bad. It's 200-300% off value, so be tedious and painful, but I'll go through and meticulously replace those as needed. And there's also the issue of that popping. I'm pretty sure that's high voltage discharge somewhere. I'm thinking maybe the DAG coating. Oh, there it is. Okay, it's not where I thought it'd be. See if the camera can pick that up. It's actually near the vertical output transformer. Oh, I'm an idiot. Well, I'm not an idiot, but when I took the side off, this support for the high voltage lead, which is metal, is just dangling. It's shorting into stuff. It's arcing into the frame. So that should take care of that. So, speaking of high voltage, I did replace the cap that was inside. I've dug up a ceramic I had on hand. See, the original was 500 picofarad rated for 10,000 volts. This is 1,000 picofarad rated for 15,000. There is another cap buried down in there. I do want to check and maybe replace. You can just kind of see it down there on the edge of it. It should be a 1 mega ohm resistor. The way they set this up is that there's a cap in here, the resistor, the high voltage lead, and then this forms another capacitor. So it forms a pi filter, a cap, a resistor, and another cap. See, do they show that? Yeah, you can kind of see that on here. There's the cap, there's the resistor, and then the CRT itself forms another capacitor. It's a good way to filter things. What I'm focusing on now is this. This was confusing. I found an electrolytic in here. I think it was 10 microfarad or 5 microfarad. 5 microfarad, 50 volts. Cathode bypass in the horizontal output tube. That's odd. It's usually much smaller. And in fact, on the schematic, on both flavors of the schematic, they show, well, it's pretty hard to see on this small print here, but it's 0.22 microfarad on both the SAMs and the riders. 0.22 to 5 microfarad, that's a pretty big swing. So I've been experimenting with different values. Here's a 0.47. Right now I do have a 4.7 in there. I want to try removing that and tacking this in place, and I'll try 0.22 as well, because it kind of looks like this was original, but I can't 100% say for certain. I think that 808 might mean the 8th week of 1948, which would be period correct for this set, but I've never, at least I don't recall ever seeing a cap this big for a cathode bypass in a horizontal output tube. So yeah, I don't know. I figure I'd experiment with values, and if the smaller value seems to work fine, I'll go with it. Alright, let's see how it works. Man, when you turn this thing on, those 2 amps that it sucks down, the whole thing kind of vibrates. I'm playing around with this switch a little bit too. It kind of works, even with that one wire disconnected. The image size does change. I'll try to demonstrate, assuming this thing even fires up. And man, is the sound booming on this thing now. It's just too darn loud. Alright, so that's with the 0.47 microfarad. Well, to compare it to the 10 and kind of go back and forth and see what difference it makes. Alright, I'll try to change that switch position. So there, it's pretty well filling the screen. And now it is very much filling the screen, the vertical change. Actually, they both changed, I think. Or no, the vertical changed for sure. So there's the smaller version, and there's the bigger version. Linearity's messed up, and there's all those adjustments on the back. I'm sure I'll have to go through all that. Smaller, bigger. So as far as where the recap stands, I finished all up in here. All the horizontal stuff, phase discriminator, horizontal output tube, all that stuff is done. What I need to go through is the resistors on the IF that are way out of spec, and the final thing will be the power supply and vertical integrator. I took the plunge and got down in there. It wasn't all that easy, but I did rebuild the vertical integrator, which is right below where I'm pointing, and I have this set upright now. It's playing pretty well. The sound is booming. Picture's a little grainy, but I'm thinking that's my signal source. See, what I've been doing lately in the past few projects, I have a converter box going to a splitter, and it feeds my shop TV and the set I'm working on. There are losses in this splitter, something like 3.5 dB per output. So I think I'll get a better picture when I just connect it directly.
It's just that we're awfully rushed these days.
The vertical lock is working a lot better now after that integrator's been rebuilt. Horizontal lock is pretty darn solid.
Cindy, are you
It's a little grainy. It's a little grainy. I'm not going to get too hung up on that, as I said, because of the signal source, but also haven't dealt with these guys yet. So yeah, the set's working pretty well. You could think, well, just why bother? The set's working. Well, if you saw my Westinghouse project I've been working on as well, replacing these caps made a big difference in that set. And also, as you will soon see on this RCA AT241, which I've been in the process of recapping, every time I install some new electrolytics, the image, which looks good, gets even better. So let's reserve judgment until these guys are replaced. Also want to clean the top of this up. This thing is filthy, but underneath that filth, it's gleaming metal. See how clean these sides are? I haven't done anything to these. That's how clean this top should be. All that lovely cadmium-plated steel, also known as poor man's chrome. And it cleans off real easy. I just used a little Windex on a paper towel, and it just all came right off. However, that's just cosmetic. We can wait on that. So, how do I want to do these? Well, adapt-a-cap for sure, because these two are on the type of bases that one would use with an adapt-a-cap, or that is suited for an adapt-a-cap, because the holes are already there and the mounting holes will line up perfectly. So this one's on an insulated phenolic base, so we have to make sure when we put the new caps in we don't connect the negative to the chassis, because they do not. However, on these two guys, they do go to the chassis. Now, the one in the middle is the odd man out. It does not have a wafer down below. So I'll have to figure something out. I may just end up drilling a couple holes, not the end of the world. So I'm going to do this guy first. So I think it's going to be the easiest. I can just drill these two out. And once I get the cap out, I'll read the values off of it to confirm and try to match it up with the schematic. Looks like we have 3 sections, a 40 at 450 and 210. Oh, sorry, 4 sections. A 10 at 450, 2 10s at 450, and a 100 microfarad 100 volts. One next to it, also 4 sections, 4450, 2450, 10450, and 100 at 50 volts. And this guy, 2 sections, dual 40s at 450. So I'll be using 47s at 450 for all the 40s, 10s for the 10s, 22s for the 20, and 100s for the 100s.